we'll continue our discussion on plane waves in homogeneous medium today. Let us start with our wave equation, del square E minus gamma square E equal to 0, where gamma is known as the propagation constant, which is a complex quantity, alpha plus j beta, which is also can be written in terms of the constitutive parameters of the medium, sigma, epsilon, and mu. Now, we also wrote the electric field strength in terms of its components along x, y, and z direction as AX EX plus AY EY, AZ EZ, where EX, EY, EZ are functions of the space x, y, and z. If you introduce this in the previous equation, in the differential equation, it can be separated out into three components. This is quite straightforward. We have seen it before. Now the question we are going to ask is, can we solve this differential equation? Yes, we have an idea. We know the nature of possible solutions. The differential equation, for example, if you take that first equation, del square Ex minus gamma square Ex equal to 0, one possible solution is Ex equal to E naught x e to the power of minus gamma xx minus gamma yy minus gamma zz, where E naught x is a constant quantity. It is a scalar, but it is constant. It's not very difficult. If you can visualize this straight away, del square can be written as del 2 by del x square plus del 2 by del y square plus del 2 by del z square. If you substitute Ex in that, take double derivative of Ex with respect to x, we generate gamma x square is generated, and double derivative of Ex with respect to y generates gamma y square, and double derivative of Ex with respect to z will generate gamma z square. Therefore, this will satisfy this differential equation provided gamma x square plus gamma y square plus gamma z square equal to, yes, gamma square. Correct, you are right. Similarly, we can write for Ey and Ez, where E naught x, E naught y, E naught z are constants. That's very important here. We can combine all this into a vector form. E, a vector, a function of xyz, is E naught bar e to the power of minus gamma xx minus gamma yy minus gamma zz. E naught bar is a constant phasor. Remember that it is a constant phasor. Now we will see the solution. E, a function of xyz, is E naught bar, a constant phasor, multiplied by that exponential quantity. Now we want to understand this equation. That's the idea here. So we define a vector called gamma bar. It is called wave number vector because gamma was propagation constant. So it's called a wave number vector, and it is Ax gamma x plus Ay cap gamma y plus Az cap gamma z, which is equal to gamma times An cap. An cap represents a unit vector in the direction of gamma bar. It is some vector. We don't have to worry about it for the moment. So as long as we understand that gamma bar is a vector and how its components are represented, that is good enough for the moment. We will define one more vector called position vector. Position vector of any point x, y, z from the origin is r bar, which is Ax cap x plus Ay cap y plus Az cap z. We know this. Once we know gamma bar and r bar, our creative mind asks us, can we find out gamma dot r? And gamma dot r turns out to be equal to gamma xx plus gamma yy plus gamma zz, which is exactly the exponent that is sitting in the electric field expression, and hence we can write that E bar as E naught bar e to the power of minus gamma dot r. Wow, what did we achieve? We managed to compress that long equation which is sitting in the exponential into a short compact form, gamma dot r, or gamma times An cap dot r bar, because gamma bar is equal to An cap gamma. That also we know. We keep using this form very often, so it is always a good idea to familiarize ourselves with this form. Keep coming back to this. Don't worry, I'll keep reminding you as we go along. So we have an equation for the electric field of uniform plane wave, which is given in terms of gamma and r. Now let's try to understand this equation in a from geometric viewpoint. So for that, what we do is we will draw a coordinate system. This is my favorite coordinate system. So it's a right-handed system, x and y on the horizontal plane and z perpendicular to this. Now on this coordinate system, we will draw a n cap, which is shown in the short red arrow there, and the long blue line or blue arrow represents a vector in the direction of a n cap. Now we ask the next question, what is r bar? R bar is a position vector of any point x, y, z. For simplicity, we have not shown the uh, point x, y, z. Assume that the tip of that purple arrow represents a point x, y, z. Now I would like to plot this electric field E. Whenever we want to plot something, it is always important to go to the time harmonic form. How do you go to get the time harmonic form? You multiply the phasor representation E naught e to the power of minus gamma a n dot r with e to the power of j omega t and take the real part of that. Now E naught is a complex quantity. E to the power of minus gamma a n dot r is a complex quantity. E to the power of j omega t is also complex quantity. So what we do now is we will try to write it in a slightly simpler fashion. Well, do you call it simpler? Well, no. Expanded fashion is a better way. E naught bar has a magnitude E naught bar magnitude and has a phase angle psi, which is written as e to the power of j psi. Gamma is equal to alpha plus j beta. Therefore, we separate that exponential into a quantity which gives us only the real term and a quantity which gives us a complex term. E to the power of minus j beta a n cap dot r bar is a complex quantity. Now it is easy. We have two quantities, two terms which are purely real. What are those? E naught bar magnitude and e to the power of minus alpha a n dot r, because alpha is purely real, and therefore we can take them out of the real function and then find the real part of e to the power of something which is nothing but cosine of something. So which will turn out to be cosine of omega t minus beta a n dot r plus psi. Now we ask the question, if I can think of a constant phase surface, that means a constant phase point, let's come to surface later, constant phase point uh, for a fixed time and for a fixed value of psi. Psi is decided by E naught bar, therefore psi is fixed, time is fixed. Therefore, we ask the question, what does a n cap dot r equal to constant represent? So, a n cap r dot r, let it be equal to OP equal to constant. Geometrically, it is a projection of r bar on to a n cap, which is OP, and that is constant. We know from analytical geometry that this is an equation of a plane normal to a n cap itself, that is represented by that brownish rectangular surface there. This is a plane, that is, if you choose a constant phase surface, constant phase surface happens to be a plane perpendicular to a n cap, which is the direction of propagation. So if I were to, this is a time t equal to t1. Suppose if I choose some other time t equal to t2, what will happen is this surface will be parallel to the new surface will be parallel to this surface, that is orthogonal to a n cap, but it will be either towards the front if it is a propagating wave along gamma, which is minus gamma a n dot r. If it were to be plus gamma a n cap dot r, it will be a wave propagating in the minus n cap a n cap direction. So this gives us a feel for the way the plane wave is propagating, and the constant phase surfaces are planes which are normal to the direction of propagation. E r bar equal to E naught e to the power of minus gamma bar r bar satisfies the wave equation. It's a plane wave. Agreed. Now we ask the question, does it satisfy the other Maxwell's equation? What is that? Del dot E equal to 0. Of course, if E has to be an electric field of an electromagnetic wave, it should satisfy del dot E equal to 0. So all we have to do is substitute E bar in this and evaluate the divergence of this. In order to do that, we need a result. Del dot psi A is a vector here, psi is a scalar here, is psi del dot A plus A dot del psi. If I were to substitute take the divergence of E naught e to the power of minus gamma dot r, then what I get is e to the power of minus gamma dot r, which is basically psi, and here A is E naught, and that is equal to 0. Now look at this del dot E naught. Del dot E naught is 0 because E naught is a constant phasor, constant quantity. So divergence of this constant vector is 0. So we have to evaluate only del of e to the power of minus gamma dot r. Gamma grade, you have to, del is del by del x ax cap plus del by del y ay cap plus del by del z az cap. That's straightforward. E to the power of gamma dot r is gamma xx plus gamma yy plus gamma zz. That's easy. Now you perform the derivative. First derivative, if you differentiate with respect to the x, you get minus gamma x e to the power of minus gamma x plus gamma y plus gamma z, and derivative with respect to y will give me minus gamma y, derivative with respect to z will give me minus gamma z. Therefore, this quantity on the bracket is nothing but gamma bar with a negative sign. Therefore, we have gradient of e to the power of minus gamma dot r is minus gamma times e to the power of minus gamma dot r. Very nice result. Please remember this result. Now we are ready to understand what is the meaning of del dot of this quantity, del dot of E. So we can write this reduces del dot of E equal to 0 reduces to E naught dot gamma e to the power of minus gamma dot r equal to 0. And what is gamma? Gamma bar? Gamma bar is an cap times gamma. Therefore, E naught dot an cap equal to 0. What is an cap? It is a unit vector along the direction of gamma bar. And that is a direction in which the wave is going, because all those planes were perpendicular to the direction. And E naught dot an cap is 0. That means E naught bar and an cap are orthogonal to each other. Therefore, in case of uniform plane wave, the electric field is orthogonal to the direction of propagation. That is what the beauty of electric field in satisfying the Gauss equation. Now, what magnetic field? We don't even know what magnetic field is. We'll try to evaluate magnetic field. In order to do that, we'll take this result del cross E equal to minus j omega mu h. We know E. We know how to take the curl of E. Therefore, you can find out h. Let's do that. That's very straightforward. H is 1 upon j omega mu del cross E, and E itself is E naught e to the power of minus gamma dot r. We need one more result now. In order to evaluate this, we need to use the result del cross psi A equal to psi del cross A plus del psi cross A. So here I want you to do a bit of mental calculation. Let's see. I'll try to take you through this. Let's see if we can do that. Del cross psi A. What is psi? E to the power of minus gamma dot r. What is A? E itself. Sorry, E naught is A. Now, psi times del cross A. That is psi. We don't have to worry about it. What is del cross A? It is del cross E naught bar. E naught is a constant quantity. Therefore, del cross E naught will give me a 0. So I don't have to worry about the first term. How about the second term? It is del e to the power of del of e to the power of minus gamma dot r cross E naught. That's what the term I have written here. So H is very nicely expressed here. We also know del e to the power of minus gamma dot r, which is minus gamma bar times e to the power of minus gamma dot r cross E naught, of course, that is there. And we can rearrange the terms, write it as gamma upon j omega mu an cross E. If I define j omega mu upon gamma as eta and give it a name called intrinsic impedance of the medium, then H is 1 upon eta an cap cross E. Oh, there's something very interesting here. In the earlier result, we had shown that an and E are orthogonal to each other. Now we are saying an, E and H form a right-handed system. An cross E gives me H. Therefore, An, E and H are all orthogonal to each other. So, this is a summary of a plane wave system. E is E naught e to the power of minus gamma dot r. Gamma bar n cap represents a unit vector in the direction of gamma bar. That is a unit vector in which in that direction the plane wave itself is propagating. And E naught an cap are equal to 0. That means E naught and an cap are orthogonal to each other, and H is also orthogonal to both E and an. Here we have E, H and the direction of propagation are perpendicular to each other, and this is known as transverse electromagnetic. Both electric and magnetic fields are orthogonal or transverse to the direction of propagation. Eta is j omega mu upon gamma. If you substitute the value of gamma, and you can write eta as square root of j omega mu upon sigma plus j omega epsilon. I am sure you have studied this result. The idea of putting all this together was to just refresh your memory once again so that you don't feel strange or uncomfortable with these results. Take one more step. Probably, I don't know if you have studied this part. I thought let's complete this job. Take an cross h of this equation. What you get is 1 upon eta an cross E. A cross B cross C. Result, remember that? Back cab. B of A dot C minus C of A dot B. Very useful result. What is A here? An cap. What is B here? An cap. What is C here? E bar. Therefore, you can easily straight away show that the right hand part will be An of, that is B of, multiplied by A dot C An dot E minus C E times A dot B is An dot An. What is An dot E? 0, because they are orthogonal to each other. What is An dot An? 1, of course. Therefore, we have E is equal to minus eta An cross H. Wow, what a nice result. These four equations, E naught dot An equal to 0, H 1 upon eta An cross E, and E equal to minus eta An cross H will probably help us a lot in understanding the behavior of the field of a plane wave, a uniform plane wave. If you are given E, you can find out H. If you are given H, you can find out E, and so on. By the way, if you want to show that H dot An would be 0, what would you do? You know it. Think about it. You can do that. Please show that H dot An is also equal to 0. It has to be, but just show that. So what do we do next? We'll recollect a quick one. Del square E minus gamma square E equal to 0 and gamma equal to alpha plus j beta. Gamma square is sigma plus j omega epsilon times j omega mu. You're getting bored, I know, but let's make it interesting. Let's make sigma equal to 0. What does it represent, sigma equal to 0? It represents a lossless medium. If sigma is 0, straight away you can say that alpha will be 0 because there is no loss. Therefore, gamma equal to j beta and beta will be equal to omega times root mu epsilon. We had shown this before. If you have forgotten, you can straight away see it or do it, no problem. Therefore, the differential equation reduces to del square E plus beta square E equal to 0, and the solution will be of this kind. E naught e to the power of minus j beta xx minus j beta yy minus j beta zz. And you can also think of beta bar. You can also write it as e to the power of minus j beta bar dot r bar. Yes, you can think of it. That's what I've written here. You can write it as e to the power of minus j beta bar dot r bar, where you can write beta bar as an cap beta and then write it in the same form. So the form is retained, and h is given by 1 upon eta, an cross e naught, exactly the same. Why am I writing these equations? Just to make you familiar with the forms of these equations when we are considering lossless medium. Lossless medium is much easier to understand, much easier to analyze, much easier to work with. So most of the time we will be working with lossless medium in this course. It's only when we need to go into loss we introduce loss. Otherwise, these are our equations which will make our life very simple and easy.